Okay, student, let us start today's topic, that is parabola. Okay, this is the first part of the conics, all right. And with respect to JEE Mains, it is asked on a very simple level. It is not asked on a very difficult level, right? And also we will be doing it in a very brief moment, or in not, I should not say a brief moment, but yes, very briefly. We will not go into the very depth of this chapter because it is not asked at that great level. So the syllabus for today's lecture would be all these topics that we are going to cover, and mostly by this we'll actually finish off with the parabola topic. So first of all, we'll discuss about basics of conics, that how conics are actually mathematically generated. We'll do basics of parabola, shape of different shapes of parabola, reduction to standard formula, parametric form, chord of parabola, and position of a point with respect to parabola, and intersection of line and parabola, where we'll derive the condition of tangency. Okay, and if you go by the syllabus of JEE Mains, this is what is mentioned, except that tangent portion is also mentioned, which we'll do in the other part, right? Apart from that, normals and the other condition of tangents are not particularly written in the you can say the syllabus. So we'll do them in a very basic form, right? Let's start the chapter, and we'll start with the basic of the conics. Okay, now let's start with basic of conics. So what do you actually mean by a conic? Let's understand that first of all. So conic section, every conic that we are going to talk about, that is whether it is parabola, whether it is ellipse, or whether it is hyperbola. Though I can explain you what do you mean by conic section when a cone is being cut, then how it is being cut, whether it is cut by perpendicular to its axis, slanted towards the axis, cut on both the cusp of the cone. So that's but that's a completely different topic, which I'm not going to cover in this particular lecture. All right, maybe some other time. So now cutting it short, so the conic section is the locus of a point. So now you understand locus. Locus is a moving point, right? Or it's the trajectory of a moving point. Locus of a point which moves in such a way that ratio of its distance from a fixed point, right? Ratio of its distance from a fixed point to the distance from a fixed straight line is always constant. This is the meaning of a conic section, right? So that is what we have written here is constant. And if you have to understand, so the fixed point is known as focus, fixed straight line is known as the directrix of the conic, and the ratio is called E, which is we know as eccentricity, right? So these are the three particular terms which you need to remember, right? So nothing but, as mentioned here, E is nothing but, yes, PS by PK as shown in the diagram. I'm just rewriting it so that you can mention. So this is the locus. This P point is actually the locus, right? And this is the fixed point, right? This D, yeah, so this not D, but in fact the S is the fixed point that we are talking about, right? This is the fixed point. This directrix is known as the fixed line that we are talking about in the equation. So the ratio of the point, distance of the point from the fixed point to the fixed line is known as eccentricity, and that is how the conic sections are defined. And since you are studying parabola, so for parabola E is equal to 1, for ellipse E is less than 1, for hyperbola E is greater than 1. So what you can mean by this is, for parabola PS will be equal to PK, right? Understood? For ellipse PS will be less than PK, and for hyperbola PS would be greater than PK, right? This is how we actually have to remember this. All right, another important thing which is true for every conic, so these properties, local directrix, focus, they are common to all the conics, which we'll study in everything, parabola, ellipse, and hyperbola, right? The other important aspect is the axis. So axis, or we can say this word here, axis, right? So a line through the focus, it passes through the focus and is perpendicular to the directrix, is known as axis, or in fact what we also call this as is the axis of symmetry. आप इसको या तो axis बोलो, या फिर you can also call it axis of symmetry. So why do we call axis of symmetry? Because above and below this line, above and below the line, the graphs is actually same. So this actually acts as a mirror. This is how you can remember this. So if we are going to draw the parabola will be equally divided in two parts, above the axis and below the axis. Similarly ellipse, similarly hyperbola. We'll see when we study those topics in detail, right? You will get to know what I'm talking about here in the parabola topic. Okay, then another very important thing which is common to all the conics is the vertex. So vertex of the conic is the point where the curve intersects the axis, and this is true for every conic, right? So we have done 4 important properties here. Let me just revise it for you. Focus, then we studied directrix, right? And then we studied axis, and then we also studied vertex, right? So these are the 4, you can say, basic properties of every conic. You'll find them in every conic, and we'll study them in all the 3 chapters, whether it is parabola, hyperbola or ellipse. All right. So if we were to solve that, how we have to solve PS by PK, right? So जैसे locus हम solve करते हैं. So if we want to find the locus, right? So for example, locus is this point P, right? So PS by PK is equal to E. We know this stuff. PS by PK is equal to E. What is PS? Can you tell me what is PS? PS will be nothing but under root of, yes, x minus, let's say, okay, I have taken A, so let me take it A. So x minus A square plus y minus B square. So this is nothing but PS. What will be PK? Can you tell me what will be PK? So PK will be the distance of the point P from this particular line. Let's say the equation of directrix is taken in the general form of line, right? So what we will do, we'll put this point over here, right? So it will be modulus of AX plus BY plus C divided by under root of A square plus B square, and this will be equal to E, right? And if we square both sides, can you see that you will get this particular stuff over here? So this is how you find actually. So this is the, you can say, this is one method, one of the methods to find the equation of, this is one of the methods to find equation of conic, to find equation of a conic, right? This is one of the methods, and the answer that you will get by this method will be a second degree curve. So if you simplify this, it will have all these terms. That is something which we will not do in detail because it is out of the scope of the JEE syllabus. So it will have a term of x square, it will have term of y square, xy, x, f, y, and the constant, all the terms. So this, if you can see, this is nothing but general equation of, this is general equation of second degree curve, right? Second degree curve. So all the conics are actually derived from this particular equation of second degree curve, right? So if somebody asks you that when we are already having this general equation of second degree curve, let me write it again for you, then how will you determine that out of this particular equation, right, when it will be a parabola, when it will be a ellipse, when it will be a hyperbola, and so on, right? So there are 2 kind of things that we have to remember, that when the focus lies on the directrix, right, focus lies on the directrix, that it cannot be a conic section. It will be a pair of straight lines, right? Just remember this. And the other condition is when the focus does not lie on the directrix, then we will talk about conic sections. So we'll talk about conic sections in case 2, right? Not in the case 1. So for conic sections, focus should not lie on the directrix. You can understand it this way. So for this, what you have to understand is delta. Delta is what quantity? It is determinant of 3 cross 3, AHG, AHG, right? BF, BF, FC. So this is the determinant, 3 cross 3 determinant. If you solve this, we call this as delta. How you can remember it is very easy. AHG is the first row, AHG is the first column, BF in this row, BF in this column, and then C, right? This is what is being written. So this delta, if you solve, will come out to be this. So no need to remember. In fact, you cannot remember such a big value. So we are just highlighting how you have to remember this delta, right? So if the focus lies on the directrix, then the condition for this is nothing but that delta will be equal to 0, right? And then if delta is equal to 0, then nothing but you will be considering pair of straight lines. That is the only possibility. So we'll talk about pair of straight lines if delta is equal to 0. We'll not talk about what? Conic sections, right? These are the conditions which are there when pair of straight lines have different cases. So if pair of lines is there, so that means there could be 2 real and distinct lines, right, intersecting at their point of intersection. So for that, h square should be greater than ab. If you want, you can remember them. If you are not able to remember, don't worry, it will not be asked in the paper. I'm just getting it to it because it is there in the concepts, right? So E has to be greater than 1, E equal to 1, and this. So I'm not going into the depth of pair of lines, but I am just wanted to highlight that when conic sections is there, what we will do. So for conic sections, parabola, just notice that here delta will never be equal to 0. You can see in all the 4 conditions, delta will never be equal to 0, right? Then we have also talked about eccentricity. Parabola eccentricity is 1, ellipse we know that is 0 to 1. First of all, again, eccentricity can never be negative, right? It is always a positive quantity. Can you tell me why? Obviously, because it's a ratio between the distances. So ratio of distances can never be a negative quantity, right? So it is always positive, right? The other condition that you people have to remember for this second degree curve to represent parabola is that h square should be equal to AB. For ellipse, less than, it should be greater than. And we'll do rectangular hyperbola, there is additional condition that it should be a plus b should be greater than 0. Another simple way of how to remember this is, we know that for parabola, E is equal to 1. So just remember that on two sides, one will be h square, the other will be AB. You will put equal to sign in case of parabola. For ellipse, eccentricity is, yes, less than, so put less than. For hyperbola, eccentricity is greater, so put the greater sign. So this is how you can actually remember these 3 conditions at the same time, right? Let's apply this in a particular problem and see how we have to solve and find the equation of a conic. So the first question that we are taking for this formation of equation of parabola, that is how we actually form equations. So it says find the equation of parabola whose focus is minus 2, 3. This is the focus that is given to you, and the equation of directrix that is given to you here is, right? So now start thinking how you will solve this. You do not require anything because I have already taught you how to do these kind of questions. So we know that for parabola, E is equal to what? PS by PK, right? And for parabola, E is equal to 1. We also know this fact. So can you apply this now over here? So what it will become? It will become nothing but PS is equal to PK. This is the condition that you people have to use every time for parabola, right? And if PS is equal to PK, then I can also say that PS square is equal to PK square. So now if you want to find the equation of parabola, so also we know that parabola is then a locus because all the conics are locus. It's a locus, and locus को हम कैसे लेते थे हमेशा? Let this point be h comma k, right? So what is the distance of P from the focus? Then it will be h plus 2 square plus k minus 3 whole square, right? And we have taken PS square, right? So this is our LHS. Distance of h comma k from this line would be h plus k minus 5 whole square upon h square, upon 1 square plus 2 square, right? This is 2. Why I'm not writing under root? Because I have taken square already. So this is how, this is actually the answer. That's it, over. You just have to solve this and you will get your answer. Okay, remember over here, don't get confused because you will get all terms here. What do I mean by all terms? That you will get terms of h square, you will get terms of k square, you will also get terms of hk, h, k and some constant, right? Okay, and since we were asked to find the locus, so in the locus problem what eventually we do, we replace h by x and we replace k by y. So in fact you will get terms of x square, you will get terms of y, you will get terms of xy, x, y and the constant. So if something of this sort is there, it could be a parabola. Don't just get away, because everybody know that parabola is generally y square equal to 4ax, right? I know this fact, that most of you know this. But if something of this sort is given, just do not reject it because it is not in this format. This is just one special case of parabola that we have to study. But all these equations can be equation of parabola. So for equation of parabola, what you will have to check is that delta should not be equal to 0 and h square should be equal to AB as we just did earlier. right? So this is how you actually form equation of parabola when the focus and directrix is given to you. Okay. So this is topic is basic of parabola. So for basics of parabola, what we are going to do is we have to do something called standard form of parabola, right? Standard form of parabola, which is written on your screen in a very highlighted form. So this is actually standard form of parabola, which is y square equal to 4ax, right? So this is called the standard form. All right, and this is what is actually in our syllabus. Standard form of parabolas are in syllabus. We do not have to do slanted parabolas, right? As per se, specifically for JEE Mains level, right? So if we are to talk about standard form of parabola, so first of all, this is the shape of this particular parabola, y square equal to 4ax. Everybody have done the shape of parabola, right? So I would write it as it is a right parabola, right? Why? Because it is opening towards the right direction, right? You can see it is opening towards this particular right direction. As we did earlier, it will have a focus, right? It will have axis, it will have vertex, it will have directrix. The four basic properties of any conic, right? So this is the property 1, that focus would be there. Second property, directrix, it will have axis, it will have vertex. So all the properties would be there for parabola, right? Okay. What are they? Let us do that particular stuff. And also, before going to that stuff, why we call this a standard parabola, you just remember this, that for standard parabola, we actually take axes to be either, just remember this stuff, they are either your coordinate axis, right? They could either be coordinate axis. For example, here axis is x-axis, nothing in the diagram that I have taken, right? For this particular parabola, axis is nothing but the axis of symmetry that you are talking about is the x-axis itself, right? This is the first thing that they could be, or they could be parallel to coordinate axis, right? We are not going to take cases where the axis is slanted, so that is not in the syllabus. So we are going to do two cases only, though in fact there could be different parabolas which are slanted. Only two cases have to be taken where the axis is either coordinate axis or they are parallel to coordinate axis. Okay, now let us understand different terms which are relevant towards the parabola. Okay, so let us understand the various terms which are involved here in the parabola. So for eccentricity, we know that the eccentricity of parabola is 1, right? What do you mean by axis? So we are talking about, first of all, let me just write down, we are talking about y square equal to 4ax standard parabola, right? Which is, I have just told you, is a rightward parabola. You just remember it like this, rightward parabola, because it is opening towards the right. Okay. Axis, in this case, the axis is the x-axis, or I can say y equal to 0, right? Where it is coming from, so if I have to write y equal to 0, can you see that this particular thing could be written like y minus 0 whole square is equal to 4a times x minus 0, right? So if you equate this particular thing to 0, this particular thing to 0, you will get y is equal to 0. That is why you are getting x's as y equal to 0. Had it been the case that here it was something like this, y minus 3 whole square is equal to 4ax. So what your x's would be this time? Y equal to 3. We'll do this. So that means x's is not x-axis, it is y equal to 3 line, right? That is the axis of symmetry. Then you have to talk about the vertex. So let me just highlight, this is your axis now in this particular case, y square equal to 4x, and also it is your x-axis in this particular case, right? Okay. Vertex. So vertex is the point of intersection of what? The conic and the axis. So this is actually your, let's say I am just highlighting, this is your vertex over here. Okay. So vertex coordinates, how you find vertex coordinate? This root and this root will give you the vertex of the point of vertex. So if you find the root of this particular thing, 0, this root is 0, so the equation of vertex, that is the reason we write it is 0 comma 0 for this standard case. All right. Had it been that the equation of the parabola was given to be something like y minus 3 whole square equal to 4a, let's say x plus 5, right? So then what will be the equation of the x's? We did this y equal to 3, right? And what will be the vertex then? When this quantity will become 0 at y equal to 3, right? So the ordinate of the vertex is 3, and this will become 0 when x is equal to minus 5. So this is the vertex, right? This is how you find vertex. I'll come to this. What do you actually mean by these kind of equations, right? Don't worry about them. Okay, before going to focal length or something of that sort, so we have to just talk about what is focus. So let's say this is focus, right? And the focus that you have to remember as a formula now, the focus of a parabola is a comma 0. So if I'm talking about, let me just highlight, I'm talking about y square equal to 4ax. Just keep this in mind. This is very important all the time. And what do you mean by a over here? So a is distance between vertex and the focus. So v is the vertex, focus is generally denoted by s. So a is always, a is nothing but it's a distance. So a cannot be negative in this particular, whenever you talk about parabola. So distance between vertex and you can say focus. In fact, it is not remembered like this. I will tell you later on when we will study latus rectum, but a is distance. You just have to remember this. So a will always be greater than 0 in case of parabola, right? Okay. Next step that we have to study is, let's say this is the directrix. Let's talk about the directrix also. So directrix is first of all an equation which is what? It's a equation line which is perpendicular to the axis. And the equation of directrix for this particular parabola is x is equal to minus a. Or you can say x plus a equal to 0. Okay. So if you notice, this distance is also a. So the directrix is at a distance of a units from the vertex. Very important rule that you should remember, right? That v lies midway between focus and directrix. Very important result. I'll use this in questions also. So v is actually midway between focus and directrix. Very important result. Okay. Then let us go ahead and do other properties which are remaining. So the next property that we are going to do is the focal chord. So as the name suggests, there could be various chords. So for example, if I want to draw, this is a chord, this is a chord, right? These two are also the chords, right? As a normal definition of chords. But what do you mean by focal chord? Chord which passes through the focus of the parabola. So these red and the black ones are actually focal chords of the parabola. And what do you mean by focal length? Focal distance of the chord. So this means focal distance is the, let's say if I take this point as P, right? And if somebody asks me find this distance PS. So this PS is actually equal to focal distance, right? This is known as focal distance. We'll do the formula for this as well. Okay. Focal distance. Let's take another property. So the next property that we have to understand is the double ordinate. So what are double ordinates? Double ordinates are the chords which are actually perpendicular to the axis. So all the chords of the parabola which are actually perpendicular to your axis are known as double ordinates. So these all dotted lines are actually your double ordinates, right? Why? Because they are first of all chords and they are also perpendicular to the axis. Okay. Then there is a special name written over here that it is latus rectum, right? So latus rectum is actually a double ordinate. Okay, it is a double ordinate, but a special case of double ordinate. So what speciality it has, that it passes through the focus. So this particular line, red line over here, is latus rectum because it is a double ordinate which passes through focus, right? Which passes through focus. And the length of the latus rectum, that means this, let's say if this is A and this is B, so this AB is known as length of LR, or I will rather say not latus rectum but LR from now onwards. So AB is the length of latus rectum, which we will do later on is 4A for this standard parabola, right? So these are the basic things that you should actually know about the parabola. These are the basics of the parabola. Okay. So moving ahead and talking about the shapes of the parabola. So we have already done that this is nothing but rightward parabola, which is y square equal to 4ax. Now this same parabola can be taken as a mirror image. So this would be the mirror image. In, let's say this is the y-axis. So this will be the mirror image. So then the standard form of this particular circle will become y square is equal to minus 4ax. Right? So this you were calling as rightward parabola. Right? So this would obviously then become leftward parabola, left parabola. Also then this parabola can be, the axis of symmetry here was x-axis, right? It could also be y-axis, axis of symmetry. So if y-axis is the axis of symmetry, then the parabola is written as x square equal to 4ay. How do you remember this as? The role of axis is being swapped. Earlier it was x, now it is y. So in this particular equation, just swap x and y. So you will get x square equal to 4ay. So we know this as upward parabola. Upward parabola. Right? And this is what you have actually studied in the topic quadratic equations. If you see, the shape is opening downwards. For this it will be x square is equal to minus 4ay. Right? And we will call this as downward parabola. Right? This is nothing but downward parabola. Okay. Also, another important thing to remember over here is, in these first two cases, you will get quadratic in y. Can you see this? It is quadratic in y. In these two, what you will get? You will get quadratic in x. Right? This is quadratic in terms of x. Right? Another big property that you should remember is that they are not functions. So they are not a function, the two diagrams, not a function. Whereas these two, the later diagrams, they are proper functions. We'll do why they are not functions when we study the topic functions. Okay. So there are four particular parabolas which you have to remember: right, left, upward and downward parabola. For right and above upward parabola, आप इसको ऐसे याद रखो जैसे हम न्यूटन लॉज में भी याद रखते थे, साइन कन्वेंशन. So upward was taken positive, rightward was taken positive. Similarly here also, so y square equal to 4ax will be positive. Similarly x square equal to 4ay. So that means for upward and left rightward parabola positive. For leftward and downward parabola you will take negative signs. This is how you should remember. Talking about the properties of all the four things, what you have to actually do is you just have to remember answers for this one, and we can actually deduce for these three. Let me show you how. Okay. So we know the graph of all these that I have already explained it to you in the just now. The vertex for this is 0, 0, right? The vertex was coming from, I just explained, y minus 0, x minus 0. So here also the root of y is 0, x ka root bhi kya hai 0. So this again will be 0, 0. Similarly here 0, 0, because here it is only x square. Had it been x minus something, then this case would have been different, right? So 0, 0 is the vertex. Focus. Let's talk about the focus. Focus here is a, 0, right? So a is coming from this particular a, and it is rightward. So a will be positive, right? In leftward parabola, a should be on the left hand side. So that is why you are putting minus sign. So remember this like this. Here it is minus. So that is the reason it will come minus. Similarly, if we talk about the other two diagrams, so this was what? This is your upward parabola. So upward parabola में graph में देखो focus आ भी कहाँ रहा है? It is on the y axis now. Obviously why? Understand this in this first and the third case. What is the difference? That you have swapped x and y. Okay, so इनमें हुआ क्या है? इसको कैसे याद रखोगे? Swap x and y. Swap x and y का क्या मतलब है? आप एब्सिसा का रोल ऑर्डिनेट प्ले करेगा, ऑर्डिनेट का रोल एब्सिसा प्ले करेगा. So just swap these two. So if you swap these two, you will get 0, a. Here it is minus, so put minus not in the abscissa but in the ordinate, because we have already swapped x and y. This is how you should remember, right? Equation of directrix, x equal to minus a. Just replace it by a negative sign, so it becomes x equal to a. Here it was x, just replace y, so it will become y equal to minus a, and similarly positive. Equation of x is y equal to 0, that means nothing but x axis, right? If you even put negative, so in this case minus was coming on which side? X side. So understand, whenever we are putting this minus, we are actually replacing x by minus x, right? Do this equation has x anywhere? So do not worry about it. It is only y equal to 0, right? So here swap y with x, so x equal to 0, and similarly x equal to 0. Equation of tangent at x-axis or at vertex, right? Vertex पे tangent ये वाली लाइन हो गई, ये वाली y-axis. इसमें भी क्या है y-axis. इस बार क्या हो जाएगी इन दोनों के केसेस में x-axis, x-axis. So you can easily write it. And we'll do this in later on, that what is the parametric form. We'll do this later. Don't worry about it. Okay. Also, if we want to talk about another two properties, that is length of LR. One is length of lattice rectum, right? So length of lattice rectum is equal to 4a. Now why this 4a? That you were writing y square equal to 4ax. Okay, let me write a y square equal to minus 4ax for this, and this is y square equal to 4ax, right? So just remember, the coefficient of x is actually length of lattice rectum. Here coefficient of x is minus 4a, so we'll take modulus and this will become 4. Similarly, for x square equal to 4ay, the coefficient of y here will give you length of lattice rectum, and similarly here also the modulus of the coefficient of y will give you length of lattice rectum. So for example, if here it was written that x square equal to minus 12y, right? So the length of lattice rectum is not minus 12, it is only 12. Whatever is written ahead of 12y, you will take it as length of lattice rectum, right? Understood? The other property that you have to also remember is length of focal chord, right? Focal chord we did in the basics, that focal chord is the distance of a point, or not the focal chord, we'll do the focal chord later, but instead we will be going focal distance. So the other property is focal distance, that is distance of a point from the focus. So now again we try and remember it in terms of all the four particular shape of parabola. So for y square equal to 4ax, the answer is, you have to remember as a plus x. So a plus x is the focal distance. So what is x? X is the abscissa of the point, right? And a is, you already know that a is coming from here. Okay. For this y square equal to minus 4ax, right? So what we did for this particular case, that we replaced x by minus x. So the focal distance then becomes a minus x in this case. Okay, got it? For x square equal to 4ay, the formula would be same. You have a plus y. Got it? So instead of x, now it will be y. And what is y here? Ordinate of the point. It will be ordinate of P point, right? And similarly here, for x square equal to minus 4ay, the distance will, focal distance will become a minus y, right? So these four formulas is also that you have to remember. So put them in your formula list, these four things, right? For four different shapes of the. So for example, if I have to make you sure that how it is applied, let's take y square equal to, let's say, x, right? And you need to find distance from the focus from the point, let's say 1, 1, right? So this point actually lies on the parabola. Let's say this is somewhere here, 1, 1. Can you tell me the focus of this particular parabola? What will be the focus? So for focus, this is, let's say 4a. 4a का role कौन play कर रहा है? 1. So that means a is 1 by 4. So that implies focus is nothing but 1 by 4 comma 0, a comma 0, right? So the distance of this particular point from the focus would be given by a plus x. So what is the value of a? 1 by 4. Just add the abscissa of the point. So the answer is nothing but 5 by 4. That's it, over. Right? So if this was the focus, so focal distance means this particular distance. This is SP, which is being talked about. Okay? So this was about the basics. Let us apply now these fundamentals that we have done in the questions. Okay, so now let us take question when vertex and focus of a parabola is given. So for example, it is said 0, 4 is the vertex, right? So let me just write down V is nothing but 0, 4, and the focus F, or you can say we generally denote it by S, is given by 0 comma 2. So can you see a pattern here that both of these points are on y-axis because the abscissa is 0, right? So can you tell me a possible shape of this particular question? So if I draw, this is the y-axis and let's say this is the x-axis. So vertex is 0 comma 4 somewhere here, right? And if it is lying on, vertex is lying on the y-axis, right? So either it will be upward parabola or it will be a downward parabola. Can I say so? So if I have to draw actual this is the shape of this particular diagram. Why downward? Because vertex is 0 comma 4 and the focus is given to be 0 comma 2, right? So vertex के नीचे focus आ रहा है. Had it been that S has been up on the upper level of V, this would become a upward parabola. So actual this is nothing but a downward parabola. This is what I can tell you about here. So downward parabola, we know that the answer would not be y square is equal to something. It would be x square is equal to minus 4a kind of parabola. So now our target is to find this particular stuff. Let's see how we are going to do this now. So now we have got this much that our shape should be something of downward parabola and this should be the answer for this standard parabola. But this was possible when vertex was 0 comma 0, right? Do you remember how I taught you this? So if x minus h square is equal to minus 4ay. So how do you understand this particular thing is that this is the standard form. In fact, इसको आप ऐसे याद रखें, standard form of downward parabola, right? This is downward parabola. Okay, if you can remember this, then all the questions will be easy for you people. Here, sorry, x minus h and y minus k. Now it is there. Okay, so the vertex in this case is nothing but h comma k. Okay, vertex is now becoming h comma k. So now if you compare this particular standard equation with what is given to you, so your vertex is what point? So we know that our vertex is 0 comma 4. We will obtain this when you write something of this sort, x square minus 4a into, sorry, y minus 4, right? So only now what is left? We also need to find the value of a. What I told you about a. What is a? A is always the distance between vertex and focus, right? So what is the distance between vertex and focus here? 2 units. So nothing but I can say a is 2. Now you have got your answer. So x square is equal to minus 8 y minus 4. Can you see the answer now in the question? So your answer becomes x square plus 8y is equal to 32. This is the answer we are looking for. And this is how you solve questions like this, when the vertex and the focus is given to you. So the C is the option we wanted. Okay. So just compare them with your major standard formulas, right? I'll cover this in just a moment, right? What do you mean by these standard parabolas? Okay. So now let us take another question when the vertex and focus is also again given. So now here vertex given to you is minus 1 comma 2 and the focus that is given to you is now 3 comma 4, right? But the problem is now they do not lie either on x-axis or y-axis. In our earlier question, both the vertex and the focus were lying on y-axis, right? Remember, I can just show you back. So here notice that both your vertex and focus lie on what? Yes, they lie on y-axis, right? But here in this problem, they do not lie on either x-axis or y-axis. So why I have taken this question is this is an example of slant hyperbola, or not hyperbola but slant parabola, right? Then we have not studied slant parabola. Then how to solve this particular question? Can you tell me? So if I have to draw a rough diagram, let me draw a rough diagram for you. So this is the particular diagram that you can say this question will have, right? mind the diagram because it is difficult to draw with this particular kind of pen that I'm writing with, right? So this is slanted in a way. So we know the focus, we know the vertex. For parabola, what you people require is, for parabola, can you tell me for parabola what you people require? For parabola, you require focus and directrix. If you have these two things, then you can tell me the equation of parabola. So we have the focus. Now what is actually required is nothing but directrix, right? Remember, very important stuff. So again, highlighting with the help of a formula that all these standard parabolas, that is y square equal to 4ax or y square equal to minus 4ax, right? They are valid only when axis is parallel to coordinate axis, right? Coordinate axis, or they are parallel, they are actually coordinate axis, right? In fact, I can add this also here. So they are only valid when they are, the axes are parallel to your coordinate axis. Here it is a slant parabola, so we cannot apply formulas of this sort here. Be very careful. So now we have the focus, we need to find equation of directrix. So now can you tell me this, if this is the axis, can you tell me the slope of axis, m of axis? You have 2 points on the axis, easily you can find 4 minus 2 upon how much? Tell me quickly. 4 minus 2, 3 minus, yeah. So it is 4. So this comes out to be 1 by 2. So can you tell me directrix slope? We know that directrix and the axes are perpendicular to each other. So this, yes. So the slope of the directrix is minus 2. So now if you can tell me any point on the directrix, we will get the equation of the directrix. So for this particular point, I told you that, let's say this is M. V is the midpoint of S and M. V is midpoint of S and M, right? So if V is the midpoint, just calculate the value of M then, because you know the V and S. I'm leaving that part for you. I'm just writing the portion of M, right? So this will be the actually midpoint of your what is required, right? Not the midpoint, but what is actually required in the question. So if M is there and the you have the slope of the directrix, can you tell me the equation of directrix then? We can easily find the equation of directrix now. So what will be the equation of directrix now? It will be y minus 0 is equal to minus 2 times x plus 5, right? Or I can say y plus 2x plus 10 is equal to 0. Can I say so? Right? So this is the equation of directrix that we will obtain. So now you know the equation of the directrix, and you also know the equation of point focus, right? So now you can easily tell me the equation of any conic, because now we know that if we want to write equation of parabola, that will be PS equal to PK square, that is distance of the any point from focus is equal to distance of any point from the directrix. So what it would be, let's say P is any point, let's say over here is x comma y, right? So the distance of this point from the focus will become that x minus 3 whole square plus y minus 4 whole square. This is the distance of the point, the square of the distance of the point from focus, and the distance of the point from the directrix will be by putting this point in this particular equation. So this will become y plus 2x plus 10 upon what? Under root 5 and whole square. So if you solve this, right, so you will get your equation of parabola, right? So this is the answer that we are looking for. So if you solve this, what again you will get? You will get equation of second degree curve. Okay, equation of second degree. And do not worry about whether you get the answer in the standard form or not. You will not get the answer in y square equal to 4x form. It will definitely be equation of second degree curve. So, but I have told you two questions that are completely similar, but the approach is completely different. So the earlier question here was having both focus and vertex on axis. Here the focus and vertex were on an inclined line. So for inclined line, this is how you have to solve. Okay. So now explaining you the concept when how to write parabolas when the axes are not the coordinate axis, and in fact they are parallel to coordinate axis. This is something very important. They are not coordinate axis, but they are parallel to coordinate axis, right? So the first one is y minus k square is equal to 4a x minus h. So how you can say this? This is something, let me draw like this, right? So this is the coordinate axis. Now the parabola is something here, something like this, right? It is not on the axis of symmetry, is not the x-axis down the line. In fact, axis of symmetry is something like this. Now axis of symmetry is not x-axis, it is parallel to x-axis. So if axis of symmetry is parallel to x-axis, your equation of parabola would sound like this, something of this sort. Okay, and what will be the equation of axis then? If I have to talk you about axis, then the axis is nothing but the root of this. So what is the root of y minus k? So y is equal to k is the axis over here, right? If we have to talk about the vertex, vertex is this point, right? So vertex is nothing but root of this and root of this point. So root of this point is h, root of this point is k. So the vertex is nothing but h comma k, right? This is v. I hope you are getting what I'm trying to say. Let us check the property. So vertex is h comma k. Got it? Focus, nothing. So if it is a rightward parabola, right? So you will just add a to the abscissa. Got it? A is still this particular value. Okay. Equation of directrix. What the equation of directrix would be? How you convert this? So let me show you a standard process of how you solve something of this sort. So let's say if something of this is given to you, right? So what we will do, we will try and convert them into a standard parabola. Why? Let's see. And how we will do this. Replace capital Y by y minus k and capital X for x minus h. So this equation then will become what? Then this equation will become capital Y square equal to 4a capital X, right? So for this, what is the vertex? 0, 0. For this, focus a, 0, right? What is the other thing? Okay, let's say directrix. For this, directrix is x is equal to minus a, right? These are the properties that we have to do. Okay, x's in this case, let us write all the four things. So x's becomes y equal to 0 line, right? But these are the properties when you have taken the parabola as capital Y and capital X. So their x's are capital X and capital Y. But in a standard question, the x's were small x and small y. So now if I have to write this, so then the vertex will be, replace the value of capital Y by this, right? So what do you mean by this is that here capital X is equal to 0 and capital Y is also 0, right? So what is the value of capital X? So that means x minus h is equal to 0 and y minus k is equal to 0, right? So here it will become h comma k. Got it? Similarly, if do here for focus, so focus x minus h should be equal to a and y minus k is equal to 0 only. So this will give you answer what? A plus h comma k. That is what I have written over here. Check. Right? For directrix, it only contains what? X. Replace x by what? X minus h. So it is x minus h is equal to minus a. This gives you answer what? X is equal to a. Oh, sorry, minus a plus h. Check here. It was y is equal to 0. In fact, I should write capital Y here and capital X here. Okay. So capital Y is equal to 0. It becomes y minus k is equal to 0. So the equation of the x's is y is equal to k. That is what I have written over here. Okay. So this is how you actually can transform your this to the standard parabola y square is equal to 4ax. And now you can repeat this process for all these three other cases, right? So this is something when this is parallel to x-axis. Here it will also be parallel to x-axis, right? But on the left side, here it will be parallel to x-axis on the upward side. So if I have to draw a diagram, so diagram would be something of this for this. Let's see. Something like this for the third case. right? And the fourth case, yes, it will be something of this type, right? Got it? This is one of the cases. In fact, another case that you can draw for this one also is this, where the axis of symmetry now is not y-axis, it is parallel to y-axis. Similarly, for this you can draw something of the parabola here. Axis is now parallel to y-axis and so on, right? So if you are able to get hold of this particular first one, right, you will be able to apply all of them in the remaining cases. So just focus on this particular concept. Let us solve questions on standard parabola. So the first question that we are going to solve is, it says a double ordinate. Now what is double ordinate? We know it's a chord perpendicular to the axis, is of length 8a. So y square equal to 4ax. Length of double ordinate, right? Length of double LDO लिख देते हैं, short form LDO is 8a. We know that length of lattice rectum LR is 4a. It is double of that, so it is not lattice rectum, right? Prove that the lines from the vertex to its end are at right angles. So see what I have drawn in the, what it is asking. So P and Q are the points of which we are talking about. So it is a chord, PQ is a chord, right? It is a double ordinate because it is perpendicular to your axis. These are the endpoints, and if you join these endpoints with the vertex, vertex is nothing but 0, 0. So then you have to prove that, what you have to prove is that angle PAB or PAQ is equal to 90 degree. So this is what is the target of this particular question. So we want to prove that this is a right angle triangle, right? This is what we want to prove here. Okay, so now how we do this? We'll use symmetry for this. Now let us understand what do you mean by symmetry. Very important concept, especially in geometry. Symmetry. So we said x-axis is the axis here in this question. And in fact, I use the word for axis is, it is symmetry, right? Axis of symmetry मैंने word use करा था. So symmetry का क्या मतलब बोला था? जितना ऊपर है उतना ही नीचे है. So for example, if you say that length is 8a, so that means 8a will be divided in two portions, 4a above and 4a below, right? Why? Because it is perpendicular to your axis, and anything perpendicular to the axis will be symmetrical. So 4a units above, 4a units below. Can you see this now? 4a above, 4a below. Okay, I have drawn the diagram on a bigger scale to make you people understand. So this is 4a, so that means PR will be equal to RQ will be equal to 4a because it will be symmetrical both above and below, right? Now you want to prove this angle as 90 degree. So can you tell me the coordinates of P and Q? The target is to find coordinates of P and Q. Why? I'll tell you why I'm finding coordinates. So what are coordinates of P and Q? Right? Since this is a double ordinate, so that means PQ is perpendicular to axis. So that means this line is parallel to y-axis. Any line parallel to y-axis is written as x is equal to constant, right? Okay, got it? In fact, if you notice, what is PR? PR is 4a. So P में अगर मैं लिखना चाहूँ, मुझे एब्सिसा नहीं पता, मुझे उसका ऑर्डिनेट तो पता है, that it is at a length of 4a units above x-axis and it is perpendicular line also. So the ordinate will be 4a. Can I say this is? So now your target is to find this 4a, which I have already written. So this P point actually satisfies your what? It satisfies parabola. What is the parabola? Y square equal to 4ax, right? You know the value of y, substitute it here. So what this value will become? 4a square is equal to 4a into x. Got it? And this will give you x is equal to 4a. That is why I have written this P point to be 4a comma 4a. Similarly, I can say that Q point is below. So Q point will have location something of this sort, right? But if you solve this, you will again get x is equal to 4a. Why? Because this is the logic. X is equal to constant. They lie on a vertical line, so they will have constant. So if you see here, the x coordinate is again 4a. So now you have P and you have Q. Now the question is over. Why? Because you were asked to find whether this is 90 degree. So if I prove slope of PA into slope of QA is equal to -1, I'll prove my question. Can you see this? This is the condition for two perpendicular lines. So what is slope of PA? Tell me. So this will be 4a minus 0 by 4a minus 0, which is nothing but 1. What is slope of AQ? Check for the slope of AQ. It is minus 4a by 4a, which is -1. Multiply these two, you get -1. That is the answer. That means they are at 90 degree. So this is how you solve these kind of questions. Okay. Let's take another problem. It says, prove the equation of the parabola whose vertex and focus are on x-axis at a distance a and a dash units from the origin respectively. Right? Let me again make the diagram bigger for you. Okay, so we know now the coordinates of a, but where does this a point lies? Can I say a lies on parabola? Because we know that a lies on the parabola, that is for sure. So what is the equation of parabola? Y square equal to 4ax. So that means this point should satisfy this. Now substitute this over here. So this becomes 2k square, 2 into 2, sorry. 2k square is equal to 4a into 2h. Or I can just simply say k square is equal to 2ah. So if you now check, this is the second equation of our locus. What does the locus says? It says that you have to find a condition independent of h and k. In terms of h and k, which is independent of the variable. And that is what we have done. A is not a variable. Why? Because it is given in the question itself. So it's a constant. So now the only step left is to replace k by y and h by x. So this is the answer we are looking for. That's it. That simple problem it is. Okay. So now let us take another problem. It says an equilateral triangle is inscribed in the parabola y square equal to 4ax, whose vertex is at the vertex of the parabola. Find the length of its side. So now this question is completely based on symmetry. It's a very beautiful question to remember also, right? How do we apply symmetry? Let's check. The vertex is a, right? For equilateral triangle, it is also given that the triangle is equilateral. So for equilateral triangle, every angle is actually 60 degree. And since parabola is completely symmetrical about its axis, I can say that the 60 will be divided in two equal angles with this axis of symmetry, 30 above, 30 below. Right? And now if I have to take, let's say, side of the equilateral triangle as, let's say I'll take B. Right? Sorry, this is B, this is B. So this will be, yes, now you are getting, this will be B by 2. Right? Because it is completely symmetrical. Jitna upar hoga, utna hi niche hoga. Right? So now in triangle, if I talk about in triangle ABM, can you tell me what is this value of B or AM? So from this triangle also you can prove that this angle will be 30. Why? Because you know that BM upon AB is coming out to be 1 by 2. That implies that theta is 30 degree, right? So, but we are not asked to prove this 30. We want to find the value of B. So now in again triangle ABM, can I say that BM by AM is nothing but tan 30? Right? And from this, can I find the value of AM? AM will become BM by tan 30. Right? Okay. So BM is what? P by 2. Tan 30 is also, what is the value of tan 30 by? Right? 1 by root 3. So this becomes B root 3 by 2. Right? Can you tell me the coordinates of B now? Coordinates of B point. Right? So अगर AM की आपके पास दूरी आ गई है, let me highlight this for you. So if you know the distance this, so this will become the abscissa of B point. Getting it or not? So B point के coordinates हो गए आपके B by 2 root 3 और इसकी हाइट कितनी है वो तो ऑलरेडी दे रखी है b/2 बिकॉज दिस विल ऑल्सो बी 90 डिग्री राइट. सो दिस इज b/2. नाउ दिस b point lies on parabola. That's it, question over. Now satisfy this point in the equation of parabola, that is y square equal to 4ax. So if I try and solve this, what you will get is b square by 4, right, is equal to 4a into b root 3 by 2, right. So just you need to solve for b now. So from, if you try and solve this, what will be the value of b that you will obtain? So b will be nothing but 8a root 3, and this is actually the answer because this is the side of the equilateral triangle that we were trying to find, right. So very difficult problem, or I should not say difficult, but a very tricky problem at the first. But what you have to focus on and how you have to remember is that how we have applied symmetry in this particular question. So this question is important from this particular aspect. Re-revise this question 2 times at least. Okay. Okay, now next topic is the topic is reduction to the standard parabola, and this is one of the very important topics. So now we know that the standard form is something of this sort, right, or of this sort, where there is single term of y and single term of x, either quadratic in y or quadratic in x. But now what is given to you here is y square is equal to 4x plus 4y also, right. So there is a term of y square and y also, whereas if you compare with this, it only contains term of y square. So if for this, the standard, it is not in the standard form. For standard form, if it is quadratic in y, it should only be y square equal to 4ax. So now we want to reduce this to the standard form. So how do we reduce? Let's see, right. So let's say I put all the y's on the same side first of all, right. So this will be 4x here and 4y over there. Now can you see that when we were solving for parabolas which are parallel to y-axis or x-axis, what we did something of this sort. This is also a equation of our standard parabola, right. So now our target is to convert this particular into this kind of thing. How we can do this? So target is make perfect square. That is the target. You have to try and make perfect square in terms of y. This is the target, right. So how do we can make a perfect square? So y square minus 4y. So what is required here for y? Yes. So you just have to, what do you have to do? Divide by 2 and square. So that means plus 4 is required, right. So I can do plus 4 on both sides, right. Now if you see this particular component, this becomes a perfect square. I can say this is y minus 2 whole square is equal to 4x plus 4, right. And this becomes what? Y minus 2 whole square is equal to, let's take 4 common, and this becomes x plus 1. So now if you compare, this is in the standard form. Now you are asked everything, latest vertex, latest rectum, focus, and everything about this particular parabola. So now let us see how we will find all these particular properties when we are already having something of this sort. Okay, let me write it down here for you. Very important step, right. Now you have to understand, and I'm taking a very basic example to make sure that you understand the concept, right. So now we'll do shifting of x-axis and y-axis. The concept that I'm using over here is called shifting of axis, right. But I'll not get into detail of what it is actually, right. But you can, if you want to study in books, this is what I'm doing. So what I will do, I'll take capital Y is equal to y minus 2, right, and capital X equal to x plus 1, right. So now my new parabola would become y square equal to 4x, right. And now if I talk about the properties of this particular parabola, let me just write it down here. So सबसे पहले शुरू करते हैं vertex, right. What is the vertex of this particular parabola? It is 0, 0, right. But you were asked whether you were asked this parabola's vertex or this parabola's vertex. So this is the, let's say, I would say converted parabola, right. And let me write here as original parabola, right. I'll highlight what is the original parabola. So this is your original parabola, right? Which is here. This is the original parabola. So will the vertex be same? No. Why? Because here, whatever I'm writing here, right? Whatever you write in terms of x and y, it is actually representing capital X, capital Y. These are the x's. This is what is meant by shifting of x's. So now I have replaced the x's by capital X and capital Y. Whereas in the original question, what are your x's? Small x and small y. So all the answers should actually come in terms of small x and small y. So this means for this particular case that capital X is equal to 0 and capital Y is equal to 0. So now put the value of capital X. This becomes x plus 1 equal to 0 and y becomes y minus 2 is equal to 0. And if you try and solve this, this value becomes minus 1 comma 2. So this is the answer of the vertex. This is the vertex of the question that you have been given. Understood? Let us take another case. Okay, let us try and do focus. So for focus, what is the focus? A comma 0. What is the value of a? 4x. So a is 1, right? So focus should is 1 comma 0 in the converted parabola. Okay, so what is the value of capital X? So capital X is 1 and capital Y is 0, right? Again do the same step. So put capital X as x plus 1. This should be equal to what this time? Yes, so this time it will be x plus 1 is equal to 1, right? And y is still 0. So y minus 2 is equal to 0. By solving this, what you will get? Absolutely. So you will get now 0 comma 2. This is your focus of the original question. Getting the point how I am transferring from the converted to the original one? Okay. Now if we were to find latus rectum. Okay. What is the latus rectum? Latus rectum is a equation which passes through what? Focus, right? So focus इसमें क्या है? 1 comma 0 and it is a line which is perpendicular to axis. So the equation would be parallel to y axis. Can I say it will be capital X equal to 1, right? Now again you have to just do what? You have to transform this into your original question. So what it will become? Just replace capital X by the value that you have substituted. You have substituted capital X is equal to x plus 1. Absolutely. So this equation should reduce to x is equal to 0. So in this case, this is your LR, or the y-axis is the LR in this case. Okay. Now let us solve next for the directrix. So what will be the directrix? Let's say directrix, right? For this particular converted one, directrix is given by capital X plus a is equal to 0, or I can say capital X. What is the value of a? Yes, 1. So this will be equal to 0. Try and again convert this. Now I guess you are getting what I'm doing every time. So sorry, just replace capital X by x plus 1 because that is what you have substituted, right? This is the substitution that I'm using. Capital X as x plus 1. So this reduces to x plus 2 equal to 0. So this is the equation of the directrix of our required problem, right? And if we talk about the latus rectum, length of LR, right? What will be the length of LR? So for the converted case, what is the length of LR? 4a. LR का आंसर क्या होता है? 4a, right? LR, length of latus rectum is 4a. So this is 4. But if you convert, that means you are shifting. So length will not change, only the coordinates change. Very important. Let me highlight this. So length will never change. It will be equal to 4 only. So length will not change, right? Length will not change. So length of LR will be same for both of them, right? What will change is only coordinates change. So if whatever you are trying to find, if it involves coordinates, so that will change. So for example, equation will change because it is involving the coordinates, but length will not change. So LR will be same for both of them. By LR here I mean length of LR, right? That will be same for both of the parabolas. This is how you solve, or in fact reduce, a equation to our standard parabola. Okay, I hope this point is now clear. Now you can find all these properties for any parabola that is given to you. Okay, so the next thing that we have to do is the parametric form of parabola or the parametric coordinates of the parabola. So for y square equal to 4ax, the parametric coordinates are given as at square comma 280 as I have already written on the screen, right? And for example, this p point over here then can simply be called as pt. Rather than saying all these terms, we can just simply say pt, where t is the parametric point of this particular parabola, right? So now what do you understand by this? I can apply this in other properties as well. So for example, if I have to take y square equal to minus 4ax, so what will be the parametric point? Now you are getting it. It will be just put a negative sign here, right? Minus at square. So for example, if I have to do x square equal to 4ay, so what will be the parametric coordinate? Yes, as we did earlier, just swap these two. So this will become 280 comma at square. And if I have to take x square is equal to minus 4ay, so it will be what? Where you will put the minus sign now? In the ya, yeah, in the ordinate. So it will be 280 comma minus at square. So this is how you take parametric points on a parabola, right? Got it? And again, if you want to take it on a very standard parabola, let's say I'll take, let me just change the pen to a highlight. So for example, if you are talking about this, right? You want to take parametric point for this. So can you tell me what will be the parametric point now? फिर से वही step, आप सबसे पहले इसको क्या लिखोगे? Y square is equal to 4ax. So for this, the parametric point could be at square comma 280, right? But here, what is the role of x and y? Here, this means capital X is equal to at square and capital Y is equal to 280. But we need to transform this because our axis is not capital X and capital Y, right? What is this will become? You will say x minus h is equal to at square. So that implies this point will become what? H plus at square. And this point, right? Getting hold of it, y minus k is equal to 280. So this implies y is equal to k plus 280, right? So this is how you actually transform the equation of parabola into a parametric point. Got it? Let's see how we apply this in other concepts and the formulas. So we apply this particular concept in the parametric form of the parabola. We apply this in the equation of chord when 2 points on the parabola are given, right? So I have drawn the diagram for you people. So let's say this is A point and I take now in parametric coordinates, that is T1. This is B point and the parametric coordinate of this point is given to be T2 and this is the focus, right? Okay. So let's say I have taken the case of focal chord. For example, for the timing, you don't consider that this AB passes through focus, right? This is any general chord. So how do you find equation of chord? I can say that A, if it is T1, right? I have assumed it to be T1. So it will become what? This point will be A T1 square comma 2A T1. And similarly B, if I have written it to be T2, this point will become what? A T2 square comma 2A T2. So now you know 2 points, you can easily find the equation of line, any line. If you 2 points are given, see this is what I am doing here. Y minus y1 is equal to m times x minus x1, right? So if you try and solve this, this gets simplified to a very beautiful answer. Y into T1 plus T2 into 2 times x plus A T1 T2. So if you want to remember this, you can remember this something like this. Y into T1 plus T2 is equal to 2 times x plus A T1 T2. Remember again, we are trying to solve this for y square equal to 4ax. This is the standard parabola that we have taken, right? You have to remember this, okay? Now taking this further, let's say we have already done that the equation of the chord passing through 2 points T1 and T2 becomes what? Y into T1 plus T2 is equal to 2 times x plus A T1 T2. We just did this, right? Now we want to try something for the focal chord. What if this chord passes through the focus? Focal chord means the chord passing through the focus, which I have highlighted. So now this chord passes through the focus S. So what condition I can find? What is the focus for y square equal to 4x? So for y square equal to 4ax, I know the focus becomes a comma 0. So if this line passes through this point should definitely satisfy the equation of this line. And if you substitute this point here, this becomes c 0 2 times a plus a t1 t2, and this simply can be reduced to t1 t2 is equal to minus 1. Very, very important result. Remember this by heart, this very important. So this becomes t1 t2 is equal to minus 1, that I have already written. So for a focal chord t1 t2, the product will be minus 1, right? And if you want to find the length of the focal chord, right, what is the length of the focal chord? So let's say this is t1 and this is t2. So what will be the magnitude AB, right? Under root of what it will become? AT1 square minus AT2 square whole square plus 2AT1 minus 2AT2 whole square, right? This will be the value of AB. Can you see? And if you try and solve this, what it will become? So you can take a common, this will become a square. You can take 2a common here as well, right? Let me just write it for you very quickly in short form. So it becomes a square t1 square minus t2 square. Here you will get what? 4a square t1 minus t2 square. Sorry, this square will be outside. All right, this will be outside here. Okay, so what you can see that just rub this off. Yeah. So what is getting common? You get a common. You also get what? T1 minus T2 common. It is here, right? So it becomes T1 minus T2 also comes outside. What is left inside is T1 plus T2 whole square plus 4. This is what is left. Now, if it is a focal chord, what you can say? T1, T2 is minus 1. So can I say that this becomes T1 minus T2, right? Under root of what? T1 plus T2, let it be written simply as this. And if I say that this is minus of minus 4, any problem in this? Right? No problems. But can I replace this minus 1 by T1, T2? So this, let's see what this will become. This becomes a T1 minus T2 and under root of what? T1 plus T2 whole square minus what? Yes, 4 T1 T2. I have just replaced this minus 1 with T1 T2 because this is a focal chord. Now if you see this, nothing, this reduces, this particular stuff will become what? T1 minus T2 whole square. Just check this out. And this completely then reduces to a into T1 minus T2 whole square. So this is the formula that again you have to remember, right? So the length of focal chord is given by a times T1 minus T2 whole square. Okay. Let us do a problem to understand the concept. All right. It says that show the focal chord of the parabola. So again, focal chord is given. So we know that any point that we take, 2 points, T1, T2 is equal to minus 1. This is given, right? Because it is a focal chord of the parabola. So parabola that is given is standard parabola, no problems. Makes an angle alpha with x-axis is of length this, right? So you are given the angle which the focal chord. So focal chord, it is given makes angle alpha, right? It makes an angle alpha with x-axis. This is given, right? So that means the slope of this line is given. If x angle is given, that means m is equal to tan alpha. Okay, so this is given to you, that the length, the slope of the focal chord. And what will be the value of m in terms of t1 and t2? Since these points are what? A t1 square, comma 2a t1 and a t2 square, comma 2a t2. So can I say this will be nothing but equal to 2a t2 minus t1 upon a times t2 square minus t1 square. And if you see, this cancels out and gives you 2 by t1 plus t2. This is given to you that tan alpha is 2 times, no, 1 upon T1 plus T2. Okay. Or in another way, I can say that T1 plus T2 is 2 by tan alpha or 2 times cot alpha. Any problems till now? Right? What you need to prove is you want to find the length of the focal chord. What is the length of focal chord? We just derived the formula for this. So length is nothing but what? A times T1 minus T2 whole square. Right? We know the value A, let it be there. So you want to write T1 minus T2 whole square, but you are given the value of T1 plus T2, which is very simple. What you can say? T1 plus T2 whole square minus 4T1 T2. Right? This will become what? T1 minus T2 whole square. And also, since this is a focal chord, I know that T1 T2 is minus 1. Why? Because this is property of focal chord. Right? So this actually reduces to what? Just replace the values. So it will reduce to 4 cot square alpha, and this will become plus 4. So this becomes 4a cot square alpha plus 1, which is nothing but a very normal trigonometry formula, 4a cosecant square alpha, which is the answer we wanted to prove. Right? Got it? So this is how actually we used the concept of focal chord in questions. Let's take another problem. So the next question says that you have to find the length of the focal chord of the parabola y square equal to 4x at a distance b from the vertex when the length is c. Right? So let's say this is a and this is b. I assume b to be t2 and a to be t1. Right? So I am given length ab. This is given to me b as c, and I know this value would be what? A times T1 minus T2 square. This is the formula that we have already done. Right? Now the important point in this particular problem is that at a distance b. Right? So what many students do generally, that first of all it is a focal chord. So that means this point is S. Right? It passes through the S. So they take S as b comma 0. What they assume that S is nothing but b comma 0 is completely wrong. What is meant by this question is, let me highlight. So the diagram that I have drawn, I have extended this line AB. What do you mean by distance? Distance always mean perpendicular distance, right? So it is given that perpendicular distance B from the vertex. So this is the vertex. So if I drop a perpendicular on this line, let's say this is C. Now this VC is given to be B, not this VS. So in this question, the error that we generally do is that we take VS equal to B. It is not equal to B. In fact, VC is equal to B. That is, distance of the line from 0, 0 is given to be B. This is what is given to you people. Okay. So what is the equation of AB? That is the focal chord. So we know that focal chord is y into T1 plus T2 is equal to 2 times x plus a T1 T2. And since this is a focal chord, so what is the property of focal chord? That T1 T2 will be equal to minus 1. Right? So I can say this becomes y T1 plus T2 is equal to 2 times x minus a. Right? This is the equation of the focal chord. Right? So if we combine this and write, so this becomes y T1 plus T2 minus 2x plus 2a equal to 0. Now you want to find this distance VC. What is the distance VC? That is, it is VC is nothing but given to be B, but we have not utilized it till now. So what is, how we can find B? Distance of 0, 0 from this line. So how we will find distance of a point from a line? Substitute 0, 0 in this line. So this will become modulus 2a divided by, I can say what? Under root of T1 plus T2 square, right? Plus B square, which is 4. Can you tell me this? Right? So this implies I can say B square is equal to T1 plus T2 whole square plus 4, right? is equal to, if I square here also, 4a square, right? What is t1 plus t2 whole square in terms of t1 minus t2? Because I know this value also, so I somewhere have to use this case also. Remember, I have to use this also, na? Don't forget. So now again, if you see, this is something what we have already done. Can I say that this is t1 plus t2 4 square minus 4 t1 t2? Because t1 t2 is what? Minus 1. So what this quantity will then become? B square. Solve this. This will become t1 minus t2 whole square is equal to 4a square, right? And then we know that t1 minus t2 is nothing but c by a. This becomes 4a square. Just solve this and we get our answer that b square c is equal to 4a cube. And this is what we were asked to find. Let's see. Right? So remember this, what actually is important in the focal chord concept is this particular stuff. People generally get confused here. This is the major important step. The t1 plus t2 whole square plus 4 can be converted to t1 minus t2 minus 4t1 t1 plus t2 whole square minus 4t1 t2, which can then be converted to t1 plus t1 minus t2 whole square. So this is the major important concept that you have to remember in focal chord. Okay. So this concept is now position of a point with respect to parabola. So let's say parabola is y square equal to 4ax. So now if this is the parabola, so let's see how many sides are there in a way. So this is the first place where the point P can lie, that is inside the parabola. In a way you can say inside the parabola, right? Bounded by the circumference of the parabola. The other is that they can lie on the parabola. This is the condition of on the parabola. And the third can be outside the parabola, right? Again, these three cases: outside, inside, on. So first of all, as we did in the case of circles, let us write the expression of the parabola as s. So this is given by y square minus 4ax, right? This is the expression of the parabola. And if you want any point P, that whether P is here or P is lying here or P is lying outside. So let's say P point B, x1, y1. So we will determine S1. S1 is what? This value, right? By substituting the values of point P in the expression. So if S1 comes out to be greater than 0, right? This is outside point. If S1 comes out to be equal to 0 on the parabola, obviously, and if S1 comes out to be less than 0, it is inside the parabola. It is very standard. It actually, if you remember, this is what we did in case of circles also, and this is the same thing which is happening in case of parabola. The only difference is that the value of S1 has changed. Only this syntax has changed. This condition though remains the same. Let us apply this in a particular problem to understand it. So the question says find the real values of A, right, for which the point, this is the given point, right, lies in the smaller region bounded by, so another very important word, bounded by the circle and the parabola. So I have drawn the circle and the parabola for you. So this is the rightward parabola, y square equal to 4x, right, where the vertex is origin, and this is the circle which is centered at origin also, right, y square equal to 4. Now you want to find the smaller region bounded by. So what do you mean by bounded by? Bounded is almost when you say it is a fixed quantity, bounded by all the from all the directions. So if you see, what we need to find is this particular region. This is bounded by the circle and the parabola both. So you want to find this region. If this is the region that it is talking about, you want to find the values of A for which this point P. Now P is given to be minus 2a, comma a plus 1 lies in the shaded region, right? You want to find such values of A so that it lies in the shaded region. What is the speciality of the shaded region? Anything that you can tell me about the shaded region? Shaded region is actually intersection of two. What intersection? Inside circle, right? it is a region lying inside the circle and a region also lying inside parabola, right? Though one should not say exactly inside parabola, but that is how I am trying to explain it to you, right? So the intersection of these two regions is actually your required answer, right? So you have to apply both the conditions here. So first is the inside the circle. Let's say we'll talk about the circle component first. So for circle, again, what we'll do, SP is less than 0, right? What is the expression of the circle? I can say for this, it will be x square plus y square minus 4. Replace this point in the equation of the circle. So this will become 4a square plus a plus 1 square minus 4 less than 0, right? And if you try and solve this, this becomes 5a square plus 2a minus 3 less than 0. And if you break them in the factors, this will be the two factors which you can form. And if you apply the wavy curve method, so wavy curve method says it has two critical points. One is -1 and the other being 3/5. So positive, negative, positive. You require what answer? Yes, you require the less than 0. So less than 0 is this region. So for this particular part, it says that A should lie between -1 to 3/5, right? Now let us try and solve for parabola. The second step that we have to do is for parabola. So for parabola, what is the expression now? For this, S would be y square minus 4x. Now for this, SP should be less than 0, right? For this also, SP should be less than 0. So now substitute this point in this expression. So what this will become? A plus 1 whole square minus 4 into minus 2a. This should be less than 0. And if you notice, this becomes a plus 1 whole square plus 8a less than 0, right? Which reduces to nothing but a square plus 10a plus 1 less than 0, right? Though you cannot middle term, it is not solvable by middle term splitting. What you can do, you can solve by simple quadratic method also. Or even if you want to solve it by squaring on both sides, so what you can do, a square plus 10a plus 24 added on both sides, this becomes 25 and less than 24, right? I have added 24 on both sides. So this becomes a plus 5 whole square minus 24 less than 0. This is how you solve inequalities, right? Okay, so let me do it here. So this becomes now a plus 5 plus root 24, right? Into a plus 5 minus root 24 less than 0, right? This is how you solve. So if I draw this on the number line, now this question is nothing but of a wavy curve method. So okay, this point would be what? Can you tell me what this point would be? Yes, so the leftmost point would be minus 5 minus root 24, and this would be minus 5 plus root 24, right? And again plus minus plus. Which region do you require? You want the answer for less than 0, so that means this particular region is again the answer. This is where the negative answer will lie, right? And what we were asked to find is the intersection of these two regions. So you need to find intersection of this answer and this answer, right? So for intersection, let us draw them on the number line. So this is the, let's say, -1 point, right? Minus 5 minus root 24 is almost the most negative number. Why? Because it is almost equal to minus 10, because root of under root minus 24 will be minus 4.9 something, right? So this is the most negative number. Then you have minus 5 plus root 24. Can you say that this is almost a negative number again, right? So this will be the third quantity, and then you have 3/5, right? So this is how you will plot them on the number line. So this answer says that it will take values ranging from -1 to where? 3/5. This is how it will be drawn on the number line, right? And the other thing that we have to plot is this particular answer. This says from minus 5 to minus root 24. This will go on till this region, right? So what is the intersection of these two regions where they are common? Obviously you can see the answer now. So this is the particular region where both of them are being satisfied. So that means the answer to A is nothing but -1 to -5 plus root 24. This is how you are going to solve this problem. This is the answer we were looking for. In this case, we have applied both the position of a point with respect to a circle and position of a point with respect to parabola. This is how you solve questions on position of a point. Okay.